Hello everyone, I am Golden Ashwini. I am here to present error detection and correction. So basic definition, general definition of terms, definitions of error detection and error correction. So error detection is the ability to detect the presence of error caused by noise or other impairments during transmission from a transmitter to the receiver likewise. Okay, so error correction is the additional ability to reconstruct the original error free data. Okay, basically there are two basic ways to design the channel code and protocol for a error correcting systems. Okay, automatic repeat request ARQ and forward error correction FEC. What is meant by automatic repeat request? That means the transmitter send the data and also an error detection code which the receiver uses to check for errors and request retransmission of erroneous data. Okay, so in many cases the request is implicit. The receiver sends an acknowledgement of correctly received data and the transmitter resends anything not acknowledged within a reasonable period of time. Then the next one is forward error correction. That means the transmitter encode the data with the error correcting code and send the coded message. The receiver never sent any messages back to the transmitter. So the receiver decodes what it receives into the most likely data. Okay, the codes are designed so that it would take an unreasonable amount of noise to trick the receiver into the misinterpret of the data. So it is possible to combine the two so that minor error are corrected without retransmission and major errors are detected and retransmitter requested. This combination is called the hybrid automatic repeat request. Okay, here error detection schemes. Okay, redundancy check, repetition schemes, parity schemes, checksum, cyclic redundancy checks, then Hamming distance based checks. Okay, here we are going to see the definition what is meant by redundancy check likewise. So redundancy check is a extra data added to a message for a purpose of error detection. So several schemes exist to achieve the error detection and generally they are quite simple. So all error detection codes, which includes all error detection and correction codes, transmit more bits than were in the original data. Most codes are systematic. The transmitter sends a fixed number of original data bits followed by a fixed number of check bits. Okay, so which are derived from a data by some deterministic algorithm. So the receiver applies the same algorithm to the received data bits and compares its output to the received check bits. Okay, then repetition schemes. Okay, variations on this theme exist. Given the stream of data that is to be sent, the data is broken up into the blocks of bits, and in sending each blocks is sent some predetermined number of times. For example, if we want to send 1011, we may repeat this block 3 times each. Suppose we sent 1011, 1011, 1011 and this is received as 1010, 1011, 1011. As one group is not the same as the other two, we can determine that an error has occurred. This scheme is not very efficient and can be susceptible to problems if the error occurs in exactly the same place for each group. Okay, then the next one is parity schemes. Parity schemes is nothing but a parity is an error detection mechanism that can only detect an odd number of errors. Okay, the stream of data is broken up into the blocks of bits and the number of one bit is counted. Then a parity bit is set if the number of one bit is odd or even. These schemes are called even parity. Odd parity can also be used. So if the tested blocks overlap, then the parity bits can be used to isolate the error and even correct it if the error affects a single bit. So this is the principle behind the Hamming code. Okay, there are some limitations to parity schemes. A parity bit is only guaranteed to detect an odd number of bit errors. If an even number of bits are flipped, then the parity bit appears to be correct even though the data is correct. Okay, the next one is checksum. So checksum of a message is an arithmetic sum of message code words of a certain word length. For example, byte values and their carry value. The sum is negated by means of 1's complement and stored or transferred as an extra code word, extending the message. On the receiver side, a new checksum may be calculated from the extended message if the new checksum is not 0 and error has been detected. Then cyclic redundancy checks. So this is more complex error detection method, makes use of properties of finite fields and polynomials over such fields. The cyclic redundancy check considers a block of data as a coefficient to a polynomial and then divides by a fixed predetermined polynomial. The coefficient of the result of the division is taken as the redundant data bits, the CRC. And the reception, one can recompute the CRC from the payload bits and compare this with the CRC that was received. So a mismatch indicates that an error occurred. Then the last one is Hamming distance based check. Okay, if we want to detect a d bits error in an n bit word, we can map every n bit word into a bigger, that means n plus d plus 1 bit word, so that the minimum Hamming distance between each valid mapping is d plus 1. Okay, so this way, if one receiver n plus d plus 1 word that doesn't match any word in the mapping with the Hamming distance, that means x less than or equal to d plus 1 from any word in the mapping, it can successfully detect it's an erroneous word. Okay, so even more d or fewer will never transform a valid word into the another. So because a Hamming distance between each valid word is at least d plus 1, and such errors only lead to invalid words that are detected correctly. So given a stream of m into n bits, we can detect x less than or equal to d bits error successfully using the above method of even n bit word. So in fact, we can detect the maximum of m into d errors if even n words is transmitted with maximum d errors. Then the next one is error correction. In error correction, automatic repeat request, ARQ. Okay, automatic repeat request is an error control method for data transmission, which makes use of error detection codes, acknowledgement and or negative acknowledgement message and timeouts to achieve reliable data transmission. So an acknowledgement is a message sent by the receiver to the transmitter to indicate that it has correctly received a data frame. So usually the transmitter does not receive the acknowledgement before the time out occurs. So it retransmitted the frame until it is either correctly received or the error persists beyond a predetermined number of retransmission. Okay, a few types of ARQ protocols and stop and wait ARQ, go back n ARQ and the selective repeat ARQ likewise. Okay, hybrid ARQ is a combination of ARQ and the forward error correction. Next one is error correcting code. Error correcting code. It's already we are saying this is, we can say it as a forward error correction code. It is redundant data that is added to the message on the sender side. Okay, then the next one is error correcting memory. So in this, because of soft errors are extremely common in DRAM of computers used in satellites and space probes. Such memory is structured as ECC memory. It's also called EDAC, protected memory. Such memory controller traditionally uses a having code. Although some use triple modular redundancy, even though a single cosmic ray can upset many physically neighboring bits in the DRAM. Such memory systems are designed so that neighboring bit belong to different words, so that a single event upset causes only a single error in any particular word. Okay, and so can be corrected by a single bit error correcting code as long as no more than a single bit in any particular word is affected by an error between accessors. Such a memory system presents the illusion of the error free memory. Okay, thank you. Thanks for listening.